Here we are, Math 1, Practice 2.4.1, identifying key features of linear and exponential graphs. So the first thing we want to do is just to determine the domain of the first two questions and then graph the function on graph paper. Okay. So Mikhail receives a base weekly salary of $350 plus a commission of $50 for each vacuum he sells. This function models the weekly earnings. Okay. So the idea here is, if you think about graphing this, okay, he's never going to have a negative amount of sales. Okay, so if he doesn't sell any, he'll still get $350, right? So we'd start out here at $350, and then for every vacuum he sells, he makes $50 more, right? Okay, so our domain would start here at 0. And then potentially, it would go until we limited how many vacuums he could sell. Which, honestly, could he sell any amount? Yeah, so we think in terms of infinity, so his domain would be 0 to infinity. Now his graph, we're not going to draw the line because he wouldn't be able to sell half a vacuum, okay? But it would keep going, so you'd want to draw that arrow. Okay, number 2 then says a population of insects begins with 15 insects and doubles every month. Okay, the population can be modeled by this equation, 15 times 2 to the x. So, thinking in terms of our graph, let's make a graph right here. So we'd start at 15 and then we'd double every month, right? So it would look something like this. Now, because in this case, you could have half a month and there'd be a little less than, double or whatnot. That one you would draw the line. But the same idea here is we start at the x value of 0, and then we can just keep going on months, and they can keep growing and growing, so it would be 0 to infinity for the domain again. Okay. Now number 3 says determine the key features of each function, include the x and y intercepts, whether the function is increasing or decreasing, and all the rest, and any asymptotes, which remember those are just dealing with exponentials. Okay, so we're going to do that on the next, I think quite a few of them, right? 4, 5, 6, 7, 8, 9, and looks like 10. So pretty much all the rest, that's what we're going to be talking about. Okay? So, the things that I want you to be able to write are x-intercept, a y-intercepts, a maximum, minimum. Okay? Tell me if it's a function. Is it continuous? Also, where is it increasing, decreasing? Where's it positive, negative? Domain and range. And if it's an exponential, asymptote. Okay, so looking at 3. You and your friends are out hiking. You start the hike with 50 pounds of food for the group and eat about 7 pounds each day. Identify the key features. Alright, so first off, x-intercepts. Do we have it where it touches the x-axis? We do. Okay, what is that point? Well, it's between 7 and 8, so we'll say like 7.2, 0. Okay, now y-intercept. Where's it across the y? At 50, so it would be 0, 50. Okay, so do we have a maximum and a minimum? Yeah, our highest point is that y-intercept. So 0, 50. Our lowest point happens to be the x-intercept, so it would be 7.20. Okay. Now remember, all these 4 are points. Okay, so that's how your answers should look. They should look as points. If it's a function and if it's continuous, deals with kind of yes or no. So is it a function? Are there 2 groups? 1, 2 groups. Yes. Is there a pattern? Yeah, that line shows us the pattern. Is it 1 to 1? Well, if I pick just one of these x's, will I only get 1 y? Yeah, so it is a function. Is it continuous? Probably not. it is continuous in between the two endpoints, but the fact that it ends would probably tell us that it's not continuous. Okay? Alright, now increasing. Remember, for increasing, decreasing, we look left to right. Is this ever increasing? Is it ever going up? Nope. So it's decreasing from what interval? Well, it starts at 0 and it decreases until it gets to that 7.2. So that would be our interval of decreasing, 0 to 7.2. Because remember, with these ones, we're dealing with interval notation. Interval notation deals with the lowest to the highest, usually x's. Okay, except in the case of range, then it's y's. So is it positive? Yeah, where's it positive? Well, from 0 to 7.2. It's above the x-axis. It's never below the x-axis. Our domain, it goes from 0 to 7.2. And our range starts here at 0 and goes up to 50. So it would be 0 to 50. And we don't have an asymptote because it's not exponential. So there we go. Okay, number 4, same idea. Okay, looking at this one, okay, so we've got the points, the x-intercept, okay, which, does it cross the x-axis? Yep, here at 24 it touches. So it would be 24, 0 would be the point. The y-intercept, right here at 1,200 is where we start. Okay, that's our y-intercept. Okay, does it have a maximum? Yeah, it's the y-intercept again, in this case. Minimum, it's our x-intercept again. Okay, so 24, 0. There's our points. Is it continuous? Well, this one doesn't have the line, and it has endpoints, so definitely no. Is it a function? Yes, because we have two groups, the amount owed and the months. We've got a pattern, paying it off $50 a month. And we've got, for only every input, only one output. So I can't say in 14 months he'll have paid back two different amounts. Okay? Now, this one is not increasing again, right? It is decreasing, but from what to what? Well, it starts at the x value of 0 and decreases until we get to the x value of 24. So that's our interval of decreasing, 0 to 24. Okay, is it positive? Yes, in that same interval. Is it negative? Never. What's our domain? Now technically, because these are points, our domain would just be every point, the x value, which would be 1, 2, or 0, 1, 2, 3, up to 24. But if you wrote that as 0 to 24, that's alright too. Now our range, we start down here at 0 and we go clear up to 1,200. So I could go 0 to 1,200, or technically in this case I should probably go 0 and then go every 50 until you got to 1,200. But I'll accept it as both. Okay, it's not exponential, so there's no asymptote either. So there's our functions, our features of our function, I should say. Alright, let's take a look now at number 5. So a gear on a machine turns at a rate of 3 revolutions per second. Identify the key features of this function. Okay, so is it a function? Well, we've got two groups, we've got a pattern, and we've got a one-to-one. Anytime I give you just one amount of time, you'll only have one number of revolutions. So function, yes. Continuous, okay, all the points are there, plus it keeps going, so let's say yes here. Now, what's our x-intercept, our y-intercept, and our max and our minimum? Well, first of all, this arrow tells us it's never going to stop getting up, so we have no maximum. A minimum, we do have a starting point, which happens to be the point where it crosses the x and the y-axis. So for all three of these, it's 0, 0. Okay, when it starts is the only time it touches the x and the y-intercept. Now, increasing. Well, it starts at 0, and then it's just going to keep going, right? And as it goes up, it keeps going to the right. So as it keeps going, we call that infinity. So from 0 to infinity, it will increase, which means it's never decreasing. Okay. Positive, it's always positive, so 0 to infinity again. It's never negative. What's our domain? Well, it starts at 0 again and just keeps going for our x values, so 0 to infinity. And what's our range? Well, our range starts at 0, and then it's just going to keep going up, so it'd be 0 to infinity there as well. And it's not exponential, so there's no asymptote. So there we go for that one, guys. Okay, now when we're dealing with a table, we can still kind of treat it the same way. So, with a table though, however, we can never tell if something's continuous. Okay, but the story problem can help us out. So the cost of an air conditioner is 110. The cost to run it is 0.35 per minute. So, because it's a cost can change. We can connect the dots, so we'd say yes, continuous. Is it a function? We've got two groups. We've got a pattern, and for every input, there's only one output, so yes. So now, let's take a look for a table. How do we find our x and our y-intercept? Well, x-intercepts always have some number, then comma 0. So is there a y value of 0 or an f of x value of 0? No. So we don't have an x-intercept. A y-intercept always has an x value of 0. Do we have an x value of 0? Yes, and the y value is 110. So our y-intercept is 0, 110. Okay. So do we have a maximum? Well, we only see this, so according to this, our maximum would be 120, 152. That's the highest we go. However, technically, if we look at this, you can just keep running this, so I'd probably say no for the maximum. We do have a minimum, though. If we just buy it and never run it, we would spend $110. That's the least amount we'd spend. Okay. Now, for our domain and range, our domain is the x, so it would be 0 to 120. Or if we're thinking in terms of the fact that we could continue this table, it'd be 0 to infinity. For our range, the lowest we get is 110, and then we could keep going either to 152 or to infinity, like if we consider this story problem and look beyond just the table. Okay. Now, positive, it's always going to be positive, so same as domain, right? So 0 to 120 or 0 to infinity, depending on if you're just looking at the table or going with the story problem. It'll never be negative, you'll never earn money back. Okay. In the same light, it'll never be decreasing, will it? It's always going to be increasing. So increasing would be the same as positive and the domain. 0 to 120 or 0 to infinity. Alright, now we finally have an exponential one. Okay, the stock is declining at a rate of 50% of its value every 2 weeks. The stock started at 300. Identify the key features of the graph. Okay, so x-intercept. It looks like it should be around here. But the nature of this graph, this is that idea of an asymptote actually comes into play. Because this is never gonna, you can never get half of something and get to 0. So the x-axis, or where y equals 0, that line, that's our asymptote, which means we never cross the x-axis. Okay, now a y-intercept at 0, 300. Which would also be our maximum, right? The highest point we get is 0, 300. Because of this idea of an asymptote, we don't have a minimum. Because it'll never actually get close to 0. Not close to 0. It'll never actually be 0, but it'll get really, 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 really close. Okay? Now as we look to left to right, we should realize it's never increasing, and so it's always going to be decreasing. Well, from what point to what point? Well, where x equals 0 is where we start, right? And then it just keeps going down until we get out here to infinity. So it would be from 0 to infinity, which consequently is going to be all our x values, right? So our domain is going to be from 0 to infinity as well. Okay. Our range, however, it'll never quite get to 0, but we'll use it as a boundary, and it goes up to 300. Now this is never negative, and so it's always positive, which means our positive is the same as our domain and decreasing. And there we go for that one. Okay. Alright, now we have another. So it says exponential. A wildflower species triples in 4 days. The field started with 9 wildflowers in the early spring. So down here at 9. So because this one started here, we technically don't have an asymptote. You could say where y equals 8.9, but I would probably just say no. Okay, so there's no x-intercepts, right? Never crosses the x-axis. Does have a y-intercept, that's where it started, right? At 0, 9. So we have a minimum, 0, 9, and it's just going to keep going. We have the arrow, so a maximum, it doesn't have one. Okay, is it a function? Yes, 2 groups. Pattern, 1 to 1. Is it continuous? Yes, it just keeps going and it goes everywhere in between. Now, is it decreasing? Never. Increasing? Well, it starts increasing here at 0 for x, and it's going to keep increasing until we get out to infinity. So 0 to infinity, which would also be our domain, and would also be where it's positive, right? Because it's never negative. So our domain and positive are going to be the same as our increasing from 0 to infinity. Our range starts at 9 down here, and then it never stops, so it goes up to infinity as well. Okay, so there we go for that one. Alright, last two. So an investment of 1,200 earns 3.9 interest and is compounded semi-annually. Okay, so here's our graph. So once again we can see it never crosses the x-axis, so no x-intercept. Okay, it's going to keep going up, so no maximum. It's always increasing, so never decreasing. It's always positive, so it's going to never be negative. So we're knocking out the nose, right? So it's always increasing, and it's always positive, so the domain is going to be the same as that. So it starts at 0, and it just keeps going to infinity. So 0 to infinity is the same for increasing when it's going up, when it's above the x-axis, and the domain. The range would start here at 1,200, but then it's just going to keep going up, right? It'll just keep increasing to infinity. Okay, do we have an asymptote? It's exponential, so technically right here it could be, but because it's not going to keep going that way, we would probably want to say none here. Okay. Now, does it have a minimum? Yeah, that starting point, right? So, which is also the y-intercept, and the minimum are the same thing. It is 0, 1,200. Okay. Is it a function? Yeah, 2 groups. Pattern, 1 to 1. Is it continuous? Goes between everything and keeps going, so yes. Alright, now the last one. Let's do this last one and be done with it. So, okay. So once again, this is an investment one, so it is exponential. Okay, so we have that same issue with the asymptote. You may want to say right below 3,000, there's an asymptote, but technically it doesn't keep going, so we'd probably want to say none here. Okay. So we need to look, x-intercept. Is there any y value that's 0? No, so we don't have one. Y-intercept, are there any x values that are 0? Yes. So we have one at 0, 3,000. Okay, a maximum, well, it's just going to keep going up, right? Because these just keep going up from the next one. So, if we wanted to, we could stop at just this point and say our maximum is 6, 3,281.06. But according to our problem, we probably should put none because it could go beyond this table. So it kind of depends on how you want to look at it. If it's just a table with no context, no story, then this would be the true answer. If it's got the context that keeps going, that would be the true answer. Minimum is going to be 0, 3,000. Okay. Is it a function? Yes. 1 to 1. Yes. 2 groups. Yes. Pattern. Yes. Continuous? Well, it's investment, so technically yes. Okay. Is it ever decreasing? No. Is it ever negative? No. So it's always increasing, which fits in with its domain, which also fits in when it's positive. So all three of those again are the same. So we'd start at 0, and then it keeps going either to 6, because we deal with x's, or infinity if it keeps going. Okay. So then our range is that we start at 3,000 and it keeps going up, so we could put this number as our highest range, or we could probably put infinity. Okay? Alright guys, there we go. Good luck with that, and